everyone, this is Alan from OC Nerf, and this is going to be the first of a new series called How To, and it'll be how to do something related to Nerf. And in this case, what we're going to be looking at is how to do some basic wiring. So we're not necessarily going to be taking apart a blaster today. That'll be in a mod guide in that playlist. Today what we're going to be looking at is just some of the basics of actually doing proper wiring jobs. I'm no expert at wiring. This is just something that I picked up along the hobby, watched a lot of videos, read about a lot of things, looked at a bunch of photos of good and bad wiring, and decided to keep practicing it. So I'm going to go through here the things that you're going to need definitely, and some of the things that you may need in rewiring for Nerf. So let's move this out of the way and we'll talk about that in a second. We're going to start off with the thing that you definitely will need, which is a soldering gun or soldering iron. This is a soldering iron, very small, pen-like. I have a soldering gun as well, and that's what I used to use in my earlier modifications, and I'm quite surprised at how clean those turned out, or not so clean if I dared to open them up and find out how terribly I had done in my early electrical modding. So this definitely need. I got this from Fry's. It was probably about 20 bucks. They're relatively cheap. Don't need anything too high caliber for what I'm doing for Nerf. So this suffices for what we will be using. The next thing you're going to need is you're going to be needing, where is it here? Solder. You're going to be needing some solder. So this I've had for a long time. It came with my soldering gun. Just some basic solder for the wiring. Next thing you're going to be needing is the actual wire itself. So you can use the stock wires in Nerf, but the stock wires in Nerf are rather low in their capability to be efficient transfers of energy. So what I typically use is 18 AWG, which has a lot better capability of getting the better output from your power source to your motors. So we're going to be using this for the purposes of this demo. You can obviously use the stock ones that come in your Nerf blaster if you have no intention of rewiring it, but the processes that we're going to be doing are the same. So we're going to put that aside. The other thing that you are going to need is some cutters. So these are just some small cutters that I like to use for cutting the wires. Not necessarily, perhaps not necessary, but I think it's a very good tool, is some wire strippers. And this one has the gauges listed here, and you can see the 18 gauge right there, which is what we will be using for the wires that I've laid out for this demonstration. You'll also be needing a little bit of heat shrink so that we can make sure that our joints not only are soldered correctly, but are insulated to prevent any kind of cross wiring or any kind of issues with the wiring job thereafter, and kind of holds everything in place rather nicely. Something else that you may or may not need with that is a heat source. I use a lighter, which is what will shrink this heat, which was what will shrink the heat shrink, since all it needs is some heat. You can also use a heat gun, or you can use the heat from the soldering iron. I just like to use this. It works fine for what I need it for. The other thing that you may or may not need are what you saw in the beginning, which are these. These are helping hands. These are little clamps that hold your wires together. We will be using that for this demonstration. You can keep this on or take this off, and this is just to kind of help see better or not. I don't use it too often, and the wires are large enough for me to see, so this is not terribly important. And inside of your Nerf blasters, you'll also be seeing these little micro switches. So pretty much anytime I do a wiring job, I cut these off and store them. I hold on to them. Sometimes I leave them in the blaster if all I'm doing is something quick and easy. Sometimes I just use them for other purposes. So I hold on to these because they're relatively easy to just put into some other thing that I might need, and I don't know, I don't know what that'll be for, but we're going to go ahead and talk about this for wiring as well. So, that being said, we're going to go ahead and use the red wire since it'll be easier for us to see. There's no difference between black and red wire other than what is standard and typical for negative or positive. So we're just going to use the red wire because it'll be easier to see on camera with my black table. So we'll put this aside and we'll grab a length of red wire and we'll cut it. Okay, nice and cut. There we go, straighten it out a little bit. Then we'll cut this in half, and then we'll take it from there. So we'll take this, snap this in half. Good. So now we've got two pieces of wire. Okay. First thing that we're going to do is we're going to need to strip the ends. So with that, I am going to get excuse me while I get my soldering iron warmed up here. There we go. So I'm going to get these. So for this, like I mentioned, it's got the numbers of the gauges on the side here in AWG and in mm, so that you can determine what size you need to fit it in. You'll see these little teeth in there, and the teeth, see if you can see it better here. Maybe if I could grab a piece of paper. You'll see these teeth correspond with the numbers. There we go. And what you're going to want to do is you're going to want to put the wire in between the number, in between the teeth of the number of the gauge of that wire. So since this is 18 AWG, we're going to unlock this. And we're going to take this and we're going to put it right here where the 18 is. We're going to clamp it down and we're going to strip it by pulling the wire off. Now we've got a nice stripped wire. We'll take that piece and that piece goes to the trash. We'll do it again for the other end of the wire that we're going to be putting together today. Again, putting it in where the 18 is. Taking the ends and stripping it, and now we've got a nice end piece. And that's all I'm going to use these for. I'm going to put those aside. Now I'm going to grab my helping hands, and I'm going to put one of the wires on one side. Twist a little bit. One of the wires. We've got our wires, and they've been stripped. So the next step is we're going to go ahead and get our soldering iron, and we're going to go ahead and tin our soldering iron. And the process of tinning is to take some solder and put it on the tip of our soldering iron. There we go. Then the next step, we're going to move one of these wires out of the way. And the next step here is to go ahead and make sure the camera gets into focus. There we go. Is to go ahead and tin the wire itself. In order to do that is we will get the little bit of solder that we have. It's really hard to do this around the camera. Heat up the wire and get the solder to melt into the wire. There we go. Awesome. Perfect. So we've got one end there. Now let's get the other end back up here. And we'll go ahead and tin this one as well. Now there are a couple of different ways that people solder wires together. The way that I'm showing you is to tin both ends, and to put both ends, touch both ends together, and then melt the solder and have that hold the two wires together. The other method is to kind of feed the wires, the fibers of the wires into each other, twist it together, solder the whole thing, and that'll hold it. Either way works fine. This is the way that I've pretty much always done it, so this is what we're doing for purposes of this demonstration. So now that's all tinned, as you can see here. I'm using the magnifying lens on the helping hands to really give us a good idea of what everything looks like. Now the next step, as I put down my soldering iron, is to get these wires lined up and on top of each other, just like that. There we go. Okay, so that's what it's going to look like. Make sure it's lined up right together. Try to make sure that everything stays on camera as clear as can be, and putting this together and not burn myself. Okay, I think we're almost there. Alright, now normally you would also get your heat shrink and go ahead and at this point put the heat shrink over one of the wires, because if you do it after, you're not going to be able to get the wire in there. The joints are soldered together. You'd have to desolder it, put the heat shrink on, then solder it back on again. But because our wires are open on the end here, I don't have to worry about that. And again, this is just for purposes of demonstration. So what you do want to do is, as I said, put the heat shrink over one of the wires first. So we'll put this aside for now, and we'll go ahead and solder these two pieces together. Now there's already enough solder on these, so I just need to heat the wires to melt the solder to hold them together. And when you do this, you don't want to move a whole lot once you get them heated. Otherwise you'll have a cold solder job, and that's not a good solid joint. There we go. The helping hands are a great tool for this, because they make sure that the joints are steady and are going to stay still while the solder cools. That way you don't get a bad connection by doing a cold soldering job. So I think that's all for that. I'm going to go ahead and turn off this soldering iron so I don't burn myself with it, and put it aside. And that should be cooling very nicely. So you can see here, hopefully see here, this is a nice soldering job. Everything's holding together nicely. It's not a big giant glob. That's something else to note. It's not a big giant glob of solder holding the wires together. You don't want that either. Let me make sure my camera focuses. There we go. So you don't want to have that big giant glob. You don't want to overheat your wires and end up burning them. You don't want to have a cold soldering job by putting solder on there and then moving it around a lot and not letting the joints cool close together. So this is where you want to be with your wiring. Now the next thing you're going to do is you're going to take the heat shrink that should have been slipped over already over your wires, and making sure that we have a good, there we go, focus. Okay, and making sure that you then slip this over the connection point. There we go. And then get your heat source, whether it's your soldering iron, heat gun, or in my case it's going to be my lighter, and go ahead and just pass the lighter back and forth just a little bit, enough to get the rubbery material there to heat up and shrink around the wires. So here we go. That should be all it needs. And as you can see, the wires are held together rather nicely by that solder and by the heat shrink. That heat shrink is tightening around those wires and we've got a very good solid connection point here. Awesome. Good solid piece. So I can pull and tug on this and it is not going anywhere. We've done ourselves a good job. So that's how you would connect all those joints together. Now the next thing that we're going to go ahead and look at is the switch. Okay, so now we're going to be talking about switches. So to the left here, we've got the basic switch that comes stock in Nerf blasters, and to the right here, we've got a little bit of an upgraded switch, which is a little bit better functionality, easier to get the current flow from the power source to the motors. It's just far more efficient than this tiny dinky little switch is. So we're going to put this aside for right now because I'm showing you this as something better to use than these, but I'm not going to be using it for the demonstrations. I'm going to be using this for other things. However, I've got tons of these tiny little switches. So we're going to go ahead and take a look, and here's the switch. It's got the 3 prongs here, which we're going to talk about, and it's got its little button right up here. So it's pretty simple concept, really. I'm going to go ahead and take out a pen here. And so this is our box for this switch. And we've got here our button, right? And we've got our 3 prongs. Each of these prongs means something else. So this one right here in the middle, for example, is your common. This is where you would have your power wire going through. And it is common because it is necessary if you're going to be using the switch either in its normally open or normally closed position. Normally open being, does the switch need to close the loop of the circuit when it is open, which is in the position it currently is now? Or normally closed, does the switch need to close the circuit when the button is pushed down, which is closed? So that being said, we've got this up here is normally open, and this down here is normally closed. So again, what's happening inside here is you've got, now we're going to look inside, is you've got, let's say that is your common, and this is a connecting point. So this right here would close. Let's focus on the normally open. This thing would close the circuit if it was in the open position. So now that the circuit is closed, the power is being driven through the common and out through the other end of the switch into your flywheels, let's say. Now if this was pushed down at this point, so you should have probably used different colors, but let's just say this was pushed down. Now at this point, the connection flows from here and goes right out there. So now, in this normally closed position, the power goes in and out when it is closed. Now if it's open, there's no power connection. Inversely, it's true of the normally open. If it is pushed down, then there's no connection between these 2 points and the circuit is not completed. So this is very useful in both situations. So for example, in the rev trigger, this is going to be normally closed. So you're going to be using the middle and the bottom, because when this is open, you don't want it to close its circuit, otherwise your flywheels would be revving as you're not even pushing the rev button. So now when you push the rev button, it's going to close the circuit. When it closes the circuit, the power gets sent over to the flywheels, and the flywheels rev. Now you'll notice that there might be some instances, and usually it's within the locking mechanisms, where you do want to have the normally open, but for most Nerf purposes, it's just going to be cleaning out the system, and you're just going to have the rev trigger, and the rev trigger is going to want it to be in the normally closed, so it'll be these bottom 2 prongs here. Okay, so that being said, when you solder joints together, you're going to want to make sure to connect it to the middle one, which is the common, and if it's a rev trigger, you're going to want to connect it to the normally closed. That way, as I mentioned, when it's open like this and you're not pushing down on the rev trigger, the connection is not complete. The loop of the circuit is not complete. So you're going to have to push this down in order to complete that circuit. So that's going to be very important. If you're ever in a situation where you've put everything together and you've wired it all up, and you put the batteries in it and it starts revving without you pushing the button, you may have done this part wrong. You may have put it in the normally open position, and now it's not going to stop unless you push down on the rev trigger. So that's very, very important to make sure that you don't screw that up, but it's not the worst thing that could happen. You just need to resolder it together. So the way to solder this is pretty much the same way as you would with the wire, in the sense that you would tin this end, tin the end of your wire, put it together, heat that up, and let it cool. So we're going to go ahead and get our soldering iron, and we're going to do just that. Okay, so here we are. We've got our switch and we've got our wire. I've already stripped and tinned the wire, so now we're going to go ahead and do the tinning on the normally open, the common. We're going to go ahead and do it into the common. And you'll notice here that in the wire, in the switch itself, it's got a little bit of solder already, previously from just when it was first connected to the original wires. So I'm going to go ahead and still solder it, and tin it, and make sure that it gets a nice, good connection. There we go. Just like that, just a little bit. You don't want a giant glob of solder on your connection points. Now, we're going to go ahead and get these 2 points together, just like before. And I've already got my heat shrink right here, ready to go. So I'm going to put this right onto there. Good. You want to make sure that it's not touching any of those other prongs. Otherwise you're going to get a closed connection already, and that's going to be really difficult for you to control. So we're going to do the same thing as we did with the wires. We're going to go ahead and heat up this so that it melts the solder and connects the joints. Hold it steady. Good. And now it should be cooled off and ready to go. If you notice that you don't need a whole lot of solder when you're doing these jobs. You put a little bit on the wire, a little bit on the connection point, and those little bits should be enough to connect them together. You really shouldn't be needing to put more solder on this connection point. I'm going to turn this off, turn off my soldering iron, and we're going to go ahead and take the heat shrink here. Now I can take this off. I'm going to put my heat shrink over. There we go. Connect that back together. Now this heat shrink is going to do a couple of things. One is going to help hold that joint together, but additionally, if you can see here how close these prongs are, this is going to help make sure that those prongs stay isolated from each other, and that there's no chance of perhaps the wires touching and creating a connection point, or creating a closed loop. So we're going to go ahead and heat this up. Really awkward to do from this angle, I tell you what. Okay, there we go. Should be all we need. There we go. And now we've got ourselves a connected common wire. So this was our earlier connection right here. Here's our connected common wire, and there you have it. Those should be pretty much the basic points of wiring for our Nerf purposes. You're going to need to cut wires off, connect wires together. You're going to need to connect the wires back to the switches and also back to the motors, which is the same process. You're going to need to tin the motor prong. You're going to need to strip and tin the wire. You need to put the wires and the prongs together. You're going to put the heat on there to melt them together, get the heat shrink, and close off that gap. So you've got a nice and clean connection point here. Very strong, very clean connection point. No cold soldering jobs by wiggling it around and moving too much, or making sure that the joints aren't overheated and burning the wires out. Or you also want to make sure that you're not overdoing it with the solder and putting globs and globs and globs of solder onto your joints. You don't need that, and it just doesn't look clean. So there you have it. If you have any further questions about this wiring, let me know in the comment section below, and I will do my best to answer it. Again, I'm no expert at this. This is just what I've picked up over time in this hobby, and I hope it helps some of you out there, especially those that haven't tried any kind of wiring job yet for your Nerf guns. This might give you a little bit of an indicator on how you might go about doing that, and hopefully you'll give it a shot. If you do, let me know how it goes, and again, I'm more than willing to answer any questions that you may have about it. In the future, I'm going to go ahead and do complete mod guides for actually wiring together a Nerf gun, but for this specific how-to guide, I wanted to get more specific and take more time about how to actually solder these, as likely I'm going to be going through it rather quickly in the mod guide. So catch you guys later, and Nerf on.